second topic that we want to talk about in this section here is mixture problems. Mixture problems. Now we're just going to touch the surface of mixture problems for now. Later on, if you go on and take another course, you'll get into mixture problems a little bit more. But mixture problems basically involve us taking two things, two quantities, two objects that have certain properties that we can numerically assign to them, and we're going to combine them together to produce a new thing. So you can think of things like mixing chemicals. You can think of things like mixing different types of candy, mixing different types of coffee that have different prices. There's lots of different things that we could mix. And so we begin with our first problem here. It says a store wants to sell a new blend of Colombian coffee. All right, so that's the first part. It's kind of the prelude. No real equation information, just the store wants to sell a new blend of Colombian coffee. Their motives for why they want to do that escape us right now. So our question is, how many pounds of coffee worth $10 per pound? So we have a $10 variety of coffee, and we want to mix that coffee with 30 pounds of a cheaper coffee. So we're taking our $10 per pound coffee and mixing it with 30 pounds of a $4 per pound coffee. And we want to make a new version of coffee worth $8 per pound. So we have $10 per pound coffee that we're going to mix with some cheaper coffee that we can sell for $8 per pound. Maybe people aren't happy with buying paying $10 per pound for their coffee. They want something cheaper. But you want to still be able to say, hey, it's a special, this kind of blend. And when you have some of it in it, then I guess you can kind of still get away with saying that, yeah, hey, it's a Colombian coffee blend. This kind of coffee blend. So here's our problem. We're mixing $10 per pound coffee with $4 per pound coffee, and our result needs to be $8 per pound coffee. So with a mixture problem, I like to diagram it. So I always think of it as two containers that are being put together into a third container. Now the first thing I want to do is label my containers. So I have $10 coffee, I have $4 coffee, and the mixture is going to be $8 coffee. The mixture is going to be $8 coffee. Now, what else do we know? We know that there's 30 pounds of the $4 coffee. So I'm going to write that amount across the top here. I don't know how many pounds of $10 coffee. That's what we're trying to figure out. So we have X pounds of $10 coffee, 30 pounds of $4 coffee. That means altogether we have X plus 30 pounds. We don't know what X is, but whatever it is, if it's 50, then we'll have 80 pounds of coffee. If it's 100, we'll have 130 pounds of coffee. Okay, that's what we're trying to find out. Now here's the good news about a mixture problem. Once you've set this up, we can then multiply down to get our equation. We can just multiply straight down to get our equation. So we can do 10 times x is 10x, 30 times 4, and 8 times x plus 30. So at this point we have our equation, and so we want to set about solving that equation now. So simplifying, 30 times 4 is 120, and then distributing here, 8 times x would be 8x, 8 times 30 would be 240. And so at this point we have an equation to solve for x. So we want x on one side, so I chose here to subtract off the 8x from both sides. While I'm at it, go ahead and move that 120 over to the other side as well. Okay. And then I simplify. On the left hand side, 10 minus 8 would be 2x, the 120s go away. 8 x's go away. 240 minus 120 would be 120. And then we can finally solve for x by dividing both sides by 2. So we get x equals 60. So we need 60 pounds of our $10 coffee to mix with our 30 pounds of our $4 coffee to get a mixture that costs $8 per pound. And if you think about this, it should make sense that we need more of the $10 coffee, since that $10 price point is much closer to the $8 than the $4 is. Now exactly how much we need is going to depend on the particular problem, but we definitely should have more than 30 pounds of the $10 coffee, because if we used equal amounts, then the average would be right in the middle between 10 and 4, which would be $7. Okay, so here we've solved our problem, and we've got 60 pounds of this coffee.